Ever wondered why problem-solving skills are crucial for programming in today's world? Well, let's dive into that. In the 21st century, programming has become a fundamental tool across a myriad of sectors. From healthcare to entertainment, finance to transport, coding has revolutionized the way we work, play, and live. But what really lies at the heart of programming? It's not just about understanding syntax or memorizing commands, it's about problem-solving. Problem-solving is a key skill in programming. It's the ability to dissect an issue, analyze it from different angles, and then develop a solution. It's about thinking logically and analytically. A well-versed programmer is essentially a problem solver, a detective of sorts, who deciphers the puzzle and crafts innovative solutions. Without problem-solving skills, a programmer is like a carpenter without a hammer. The tools might be there, but without the right skill, the result will be far from ideal. Problem-solving allows programmers to write efficient code, minimizing the use of resources while maximizing output. It's the difference between a clunky app that crashes and a smooth, user-friendly platform that keeps people coming back. Moreover, problem-solving in programming is not just about fixing bugs or errors, it's about innovation. It's about looking at a process or a system and thinking, how can I make this better? How can I make this more efficient? It's these problem-solving skills that have led to some of the most groundbreaking advancements in technology, from artificial intelligence to blockchain. So problem-solving in programming is not just important, it's essential. It's the skill that turns coders into creators, the skill that drives the digital world forward. As we continue to embrace technology in all aspects of our lives, the demand for skilled problem-solving programmers is only set to increase. So it's clear that problem-solving is an essential tool in a programmer's toolbox. And remember, like any skill, problem-solving can be learned and honed. So, let's get to it. Let's dive into a common programming problem for a moment. Imagine you're given an array of numbers and you're tasked with finding the largest number in this array. On the surface, it might seem like a simple problem, but it's these foundational tasks that lay the groundwork for more complex programming challenges. Or how about something a bit more intricate? Consider the task of implementing a binary search algorithm. This is a search method that finds the position of a target value within a sorted array. It halves the array with each step, greatly improving efficiency over a simple linear search. These are just two examples, but the world of programming is filled with diverse and complex problems that require a keen eye and a sharp mind. And that's where the fun lies, isn't it? Now that we understand the problem, how do we go about solving it? The first step to solving any problem is understanding it. Now let's imagine a scenario. You're faced with a complex programming task that seems like a mountain to climb. It's overwhelming and you have no idea where to start. This is where the art of breaking down the problem comes into play. Imagine the problem as a large tangled ball of yarn. Trying to unravel it all at once would only lead to more knots, confusion, and frustration. Instead, if we find an end and start to slowly unravel it, the task becomes more manageable. This is analogous to breaking down a complex programming problem into smaller, more manageable parts. This process of breaking down a problem is also known as decomposition. It's one of the fundamental skills of a successful programmer. Why, you ask? Well, decomposition allows us to tackle the problem piece by piece. Each small part can be understood and solved independently, which ultimately leads to the solution of the larger problem. Let's say, for instance, you're asked to develop a software for a library management system. If you tackle this problem head-on, it might seem intimidating. But if you break it down into smaller tasks, like creating a database for the books, developing a user interface, setting up a borrowing and returning system, and so on, suddenly the problem doesn't seem so daunting anymore. The beauty of breaking down the problem is that it gives us clarity. It helps us understand the problem better by focusing on one aspect at a time. It's like shining a flashlight into a dark room. The light may not illuminate the entire room at once, but it allows us to see and understand each part clearly. Once we've broken down the problem, we can start to tackle each part. We can brainstorm solutions, write pseudocode, and then translate that into actual code. Each small victory brings us one step closer to solving the larger problem. Remember, a big problem is just a series of smaller problems waiting to be solved. So, embrace the art of breaking down problems. It's your secret weapon in the world of programming. Once we've broken down the problem, it's time to start solving it. Now that we've broken down the problem, let's tackle each part one by one. In the world of programming, there's no such thing as a one-size-fits-all solution. Different problems may require different approaches, and even the same problem could be solved in various ways, each with its own trade-offs. So let's dive into the different approaches we could consider. First, we could go the sequential way. This is the most straightforward approach. We start at the beginning of the problem and work our way through step by step. We write one line of code, then another and another until we've addressed each part of the problem. This approach is like building a wall, brick by brick. It's simple, it's reliable, but it might not always be the most efficient. Another approach is the divide and conquer strategy. In this approach, we break the problem down into smaller, more manageable parts. We then solve each of these smaller parts independently. Once we've solved all the small parts, we combine them to solve the original problem. This approach can be more efficient than the sequential way, especially for complex problems. However, it requires a good understanding of the problem and careful planning. Yet another approach is the recursive method. This approach is a bit like the divide and conquer strategy, but with a twist. Instead of breaking the problem down into smaller parts, we break it down into simpler versions of the same problem. We then solve these simpler versions and use the solutions to solve the original problem. This approach can be very powerful, but it can also be tricky to get right. So which approach should we use? Well, that depends on the problem at hand and our understanding of it. Sometimes the best approach is a combination of two or more methods. Now let's solve our problem. We'll start with the sequential approach as it's the most straightforward. We'll write our code line by line, making sure each step works before moving on to the next. Once we've got a basic solution, we'll look at ways to optimize it. Can we break the problem down into smaller parts and solve them independently? Can we simplify the problem and solve it recursively? We'll consider these questions and tweak our solution accordingly. In the end, the most important thing is not the approach we choose, but the thought process behind it. The ability to analyze a problem, consider different ways to solve it, and then execute a solution is a valuable skill. It's a skill that can be honed with practice, and it's a skill that can make you a better programmer. And there you have it, we've solved the problem, but remember, there's always more than one way to solve a problem. Solving one problem is great, but the key to mastering problem solving is practice. Just as a musician hones their skills through relentless practice, a programmer too needs to constantly challenge themselves with a variety of problems. This not only refines their problem-solving skills, but also exposes them to different scenarios, making them more adaptable and efficient. Just imagine, with every problem you solve, you're adding a new tool to your programming toolbox. Each tool represents a new strategy, a new approach, a new solution. The more tools you have, the better equipped you'll be to tackle any programming challenge that comes your way. But remember, practice doesn't mean doing the same thing over and over again. It's about trying new things, making mistakes, and learning from them. It's about pushing your boundaries, stepping out of your comfort zone, and growing as a problem solver. So keep practicing, keep solving problems, and you'll become a better programmer. We've learned a lot today about problem solving and programming. We've covered the importance of honing these skills and how they can make us better programmers. We've delved into common problems that you may encounter along your coding journey, and we've broken them down step by step. Remember, solving a problem is like solving a puzzle. It's about understanding the pieces, how they fit together, and using your creativity to find a solution. And just like any skill, the more you practice, the better you become. So keep challenging yourself, keep pushing your boundaries, and continue to learn and grow. The world of programming is vast and exciting, and there's always something new to discover. If you found this video helpful, don't forget to subscribe to the Programmer 10101 channel, share your opinion in the comments, share this video, and hit the like button. Keep coding, keep learning, and until next time.